Something just happened 15 billion miles from Earth, and almost nobody is talking about it the way they should be. Not because the information is classified, not because the government is hiding it, but because the truth, the real, full, haunting truth, is so enormous in its implications that most people can't emotionally process it in a single headline. A machine that human hands built, that human minds designed, that launched into the sky when your parents or grandparents were young, that machine has just gone quieter, and with every passing day, it gets quieter still. The world didn't stop. No breaking news alert shook your phone. But somewhere in the cold, lightless vacuum between the stars, the most distant object humanity has ever created is dimming. And what it has already told us, and what it can no longer tell us, should stop every single person on this planet cold. This is not the story of a dying spacecraft. That framing is too small, too clinical, too convenient. This is the story of humanity's longest conversation. Nearly half a century of signals crossing distances so vast that the numbers lose meaning, and what it means when that conversation begins to fall silent. This is the story of what Voyager 1 has revealed, what it is now sacrificing piece by piece just to survive, and what an entire civilization stands to lose when the last whisper finally goes dark. And if you think you already know this story, you don't, because the version being told in most places leaves out the parts that matter most. Voyager 1 is not dying in the way spacecraft usually die in public imagination. It is not tumbling helplessly. It is not vanishing behind a planet. It is not being struck by some final cinematic disaster. It is being narrowed by watts. That phrase should sit with you for a moment. Not by distance, not by damage, not by the cold of interstellar space, by watts, by the slow, inevitable arithmetic of nuclear decay. And that is somehow more terrifying than any dramatic ending could ever be. Let's go back to the beginning. Because to understand what is happening right now in real time in 2026, you need to understand what this machine actually is, not in the sanitized textbook version, but in the full staggering weight of what was actually accomplished. Voyager 1 was launched in 1977, and it has spent over 45 years studying the outer solar system, making flybys of Jupiter and Saturn, and traveling more than 46 billion miles. But those numbers, as impressive as they sound, still fail to capture the true scale of what happened. Think about what 1977 actually was. There were no personal computers in homes. There was no internet. There was no GPS. The most advanced technology most people interacted with on a daily basis was a color television set. And yet a team of engineers and scientists, armed with slide rules and early mainframe computers, built a machine so precisely, so carefully, so brilliantly, that it is still functioning nearly 5 decades later, in a place no human instrument had ever reached. On August 25th, 2012, Voyager 1 became the first space probe to enter interstellar space when it crossed the heliopause, the outer limit of the sun's magnetic field and solar wind. That moment should have been treated as the most significant technological milestone in human history, and in many respects it was inside the scientific community. But it passed through public consciousness like a stone through still water, leaving barely a ripple. Most people went on with their lives. Most people never knew. And that is exactly the problem. Because what Voyager 1 has been doing since that crossing is irreplaceable. The data it sends back is not simply interesting. It is the only data of its kind that exists anywhere in the world, from any source, at any price. No other human-made object has ever been where Voyager 1 is right now. But here's where everything changes. Each Voyager loses about 4 watts of power every year. 4 watts is almost nothing on Earth. On Voyager 1, it is the difference between keeping one instrument alive and shutting it off. 4 watts. The amount of power a single small LED bulb uses. That is what stands between Voyager 1 continuing to speak and going permanently silent. And for nearly 5 decades, NASA's engineers have been managing this slow, relentless drain, making impossible choices about which instrument to sacrifice, which sensor to power down, which window into the interstellar universe to close forever. Think about what it means to be an engineer who has dedicated their career to this spacecraft, and to sit in a room and vote on which of its eyes to shut next. That is not a technical exercise. That is grief wearing a lab coat. The power output of Voyager 1's RTGs has been declining by about 4 watts per year. And as of April 2026, they are producing less than half their original power. Less than half. The spacecraft that launched with enough electrical power to run a small apartment is now running on fumes. Nuclear fumes, technically, generated by the heat of decaying plutonium, but fumes nonetheless. Of the 10 original instrument sets carried by the twin probes, 7 have now been switched off. 7 out of 10. Think about that ratio. 7 of the 10 scientific eyes that Voyager 1 was given at birth have already been permanently closed, and each closure was not a technical failure. Each closure was a deliberate, agonizing decision made by human beings who understood exactly what they were sacrificing and chose to do it anyway, because the alternative was losing everything faster. The most recent chapter in the story is one that received far too little attention from the wider world. On April 17, 2026, mission engineers at NASA's Jet Propulsion Laboratory in Southern California turned off the low-energy charged particles experiment aboard Voyager 1, the LECP, an instrument that had been operating almost without interruption since 1977, nearly 49 years of continuous operation, nearly half a century of measuring ions, electrons, and cosmic rays as Voyager 1 traveled first through our solar system and then beyond it into the interstellar medium. And in April 2026, engineers sent a command that took 23 hours just to reach the spacecraft, and they turned it off. The decision came after a routine roll maneuver on February 27th saw a power level drop. It nearly tripped the spacecraft's undervoltage fault protection system meant to shut down the probe and keep it in a safe mode status. Let that sink in. A routine maneuver, the kind the spacecraft has been doing for decades, nearly triggered an automatic shutdown that could have ended the entire mission. The margin between Voyager 1 continuing to function and Voyager 1 going catastrophically dark was, in February 2026, razor thin. The engineers made their decision quickly, and the LECP went dark. But here's where it gets worse, because this wasn't a spontaneous response to a crisis. The choice of which instrument to turn off next wasn't made in the heat of the moment. Years ago, the Voyager science and engineering teams sat down together and agreed on the order in which they would shut off parts of the spacecraft while ensuring the mission can continue to conduct its unique science. They planned for this. They saw it coming years in advance, and they sat together and decided the order of sacrifice. There is something profound and terrible about that image. Scientists and engineers planning the slow, deliberate dismantling of the most successful deep space mission in human history, one instrument at a time, because the alternative is losing it all at once. The current instrument table lists the low energy charged particles instrument as off to save power on April 17, 2026. That leaves only MAG, the magnetometer, and PWS, the plasma wave subsystem. Two instruments, two remaining windows into interstellar space, and both of them matter more than most people realize, because interstellar space is not empty. It is not the sterile vacuum that science fiction depicts. It is full of magnetic fields, plasma oscillations, density variations, and particle behaviors that we are only beginning to understand. And Voyager 1 is the only instrument we have that can measure them in place, directly, in real time. The magnetometer measures the local magnetic field. The plasma wave subsystem can detect plasma oscillations and other radio frequency signatures that help scientists infer the density and behavior of ionized gas around the spacecraft. In every measurement, those two surviving instruments send back adds to a dataset that is unique in all of human science. There is no telescope on Earth, no satellite in orbit, no theoretical model powerful enough to replace what Voyager 1 is doing right now. It is the only thing in the interstellar medium that can tell us what the interstellar medium actually is. And we are running out of time to listen. What most people are not seeing is the compounding nature of this situation. It is not just that Voyager 1 is losing power. It is not just that instruments are being shut down. It is that each shutdown creates a new set of risks that the remaining systems must navigate. After nearly 5 decades in space, engineers have had to steadily power down heaters and instruments while making sure the spacecraft do not get so cold that key systems, including fuel lines, are put at risk. Turning off heaters to save power means that critical components get colder. And in the temperatures of interstellar space, temperatures far below anything that naturally occurs on Earth. Cold is not just uncomfortable. Cold is catastrophic. If fuel lines freeze, the thrusters fail. If the thrusters fail, the antenna can no longer be pointed at Earth. And if the antenna can no longer be pointed at Earth, it doesn't matter how much power Voyager 1 has left. We will never hear from it again. This is not a distant theoretical risk. This nearly happened. In late 2024, engineers discovered that Voyager 1's primary X-band transmitter had developed a fault protection issue. On October 19th, the X-band transmission stopped entirely. Based on their correct assumption that the original X-band transmission issue had been triggered by Voyager 1's fault protection system, they concluded that it had happened twice more. And as a result, Voyager 1 had switched to its S-band transmitter, which hadn't been used since 1981. Think about what this means in practical terms. The spacecraft had autonomously switched to a backup transmitter that hadn't been activated in over 4 decades. A transmitter so weak that engineers weren't even sure they would be able to detect the signal from 15 billion miles away. And yet, against all odds, they found it. A whisper From the edge of the known universe, picked up by a network of giant radio dishes distributed around the planet, pieced together by people who refuse to give up on the most important scientific mission in history. Deep Space Station 43, a 230-foot wide antenna in Canberra, Australia, that is the only dish with enough signal power to send commands to the Voyagers, went offline for upgrades from May 4th, 2025 through February 2026. During most of that period, engineers could receive data from Voyager 1, but they could not reliably send commands back. They were listening, but they could not speak. Imagine monitoring a patient in critical condition and being able to read every vital sign in real time, but being physically unable to administer any treatment. That is what the Voyager team experienced for the better part of a year, and they managed it, because this is what dedication to science looks like when it operates at its highest level. And now in the midst of all this, there is something extraordinary being planned, something that could change the trajectory of this entire story. Engineers hope the latest sacrificial move can keep Voyager 1 operating long enough for the team to potentially roll out an upgrade, nicknamed the Big Bang, that could allow the record-breaking probe to continue exploring deeper into space, and perhaps even restart some of its science instruments. The Big Bang, a software and engineering overhaul transmitted across 15 billion miles of empty space, designed to essentially resurrect capabilities that have already been shut down. The ambition of this plan is extraordinary. The difficulty is almost impossible to overstate, but so is the track record of the people attempting it. Consider what they already pulled off. In November 2023, Voyager 1 stopped sending readable data entirely. In November 2023, Voyager 1's signal stopped making sense. The spacecraft was still connected to Earth, but the data it sent was scrambled and unreadable. NASA believes a single chip inside the flight data subsystem failed, possibly due to damage from space radiation or simply wear and tear after 48 years in space. A single chip, billions of miles away, on a spacecraft that was built before personal computers existed. And the engineers at JPL found it, diagnosed it, and fixed it, not by sending a repair crew, not by replacing the hardware, but by rewriting software and transmitting it across the solar system one careful command at a time. They sent it to its new location in the FDS memory on April 18th. A radio signal takes about 22.5 hours to reach Voyager 1, and another 22.5 hours for a signal to come back to Earth. When the mission flight team heard back from the spacecraft, on April 20th, they saw that the modification worked. 2 days of waiting to learn if a repair attempt had succeeded or failed, 2 days of silence while a command traveled to the edge of the solar system, and a response made its way back. And it worked. Against all odds, against all logic, against the sheer accumulated weight of nearly 5 decades of use, it worked. Now understand what is at stake in the coming years, because the timeline is accelerating. Voyager 1 is now so far from Earth that NASA says it will reach 1 light day away on November 18th, 2026, meaning a radio signal will take a full 24 hours to cross the distance between the probe and home. 1 full day for a signal traveling at the speed of light, 186,000 miles per second, to reach Voyager 1, and another full day for the response to come back. A simple back-and-forth communication that takes 2 days. By November of this year, engineers who say good morning to Voyager 1 on a Monday will not hear its response until Wednesday, and Voyager 1 will keep going. It will keep moving outward at 30,000 miles per hour of every day, forever, until physics or fate intervenes. The distance will keep growing, the signal will keep weakening, the delay will keep lengthening. With the implementation of the current power conservation plan, engineers believe the 2 probes could have enough electricity to continue operating with at least 1 science instrument into the 2030s. But they are also mindful that the Voyagers have been weathering deep space for 47 years, and that unforeseen challenges could shorten that timeline into the 2030s. That is the best case scenario. And even in that best case, it means we likely have less than a decade of scientific data remaining from the only object humanity has ever placed in interstellar space. Now think about the golden record, because this is where the story shifts from the scientific to the philosophical, from the technical to the deeply human. Bolted to the side of Voyager 1, traveling with it into the darkness, is a gold-plated copper disc containing the distilled essence of human civilization. Greetings in 55 languages, music from across every culture on Earth, the sounds of nature, the sounds of cities, the sounds of children laughing and waves breaking and thunder rolling. The golden record was designed by a team led by Carl Sagan, containing greetings in 55 languages, music from across human cultures, scientific diagrams, and a map showing Earth's location relative to nearby pulsars. It contains the brainwave patterns of Androian, recorded while she consciously thought about the history of human civilization and drifted into thoughts of falling in love. It contains a child's first words. It contains Beethoven and Chuck Berry and Bach. It contains everything we thought worth saying about ourselves if we only had one message to send into the unknown, and it is riding on a spacecraft that is slowly going dark. But the record will not go dark. The spacecraft will continue traveling outward at 38,000 miles per hour for an effectively unbounded duration. The golden record bolted to its side will continue traveling outward with it indefinitely, until some chance encounter with a star, a planet, or another civilization many millions or billions of years from now, long after the last instrument has powered down, long after the last signal has faded below the threshold of detection, long after everyone currently alive on Earth has died, long after the civilization that built Voyager 1 has either transformed beyond recognition or ceased to exist entirely, that disk will still be traveling. It will still be carrying its cargo of human expression through the dark between the stars. Whether anything will ever find it, whether anything capable of understanding it exists anywhere in the universe, those questions remain unanswered. But the record goes on regardless, an act of cosmic faith by a species that looked up at the stars and decided the universe deserved to know we were here. What most people are not seeing is that the shutdown of Voyager 1's instruments is not just a technical event. It is not a budgetary issue or a mission management decision or a footnote in the history of space exploration. It is a civilizational moment. It is the moment when humanity's furthest reach begins its final contraction. Everything about this mission was unprecedented. The distances were unprecedented. The duration was unprecedented. The discoveries were unprecedented. Voyager 1 showed us the active volcanoes of Io. It reveals the complex ring system of Saturn in detail no telescope had ever achieved. It crossed the heliopause, the boundary between the sun's influence and interstellar space, and kept going. It sent back data from a place where the sun is just another star, indistinguishable to the naked eye from any of the other stars scattered across the sky. And now, on April 17, 2026, with the shutdown of its 8th instrument, the probe was launched with a suite of 10 science, instruments intended to aid flybys of Jupiter, Saturn, Uranus, and Neptune. And today, only the magnetometer and the plasma wave. Subsystem remain 2 instruments, 2 voices, 2 final connections to the deep interstellar void that no one else can reach. And the engineers are fighting, every single day, with every tool available to them, to keep those 2 voices speaking as long as possible. If the Big Bang upgrade is successful, it could keep Voyager 1 operational through its 50th anniversary and may even allow engineers to restart the LECP instrument, the 50th anniversary, September 5th, 2027. The engineers are not just trying to keep Voyager 1 alive, they are racing to give it the gift of its own golden anniversary, to let it reach a milestone so extraordinary, so historic, so unprecedented in the entire history of space exploration, that even the most indifferent person on Earth would have to stop and acknowledge what that means. A machine built by human hands, speaking to human ears, 50 years after it left the ground. But even if the Big Bang works, even if Voyager 1 reaches its 50th anniversary and beyond, the math is relentless. Sometime in the 2030s, if the spacecraft survives that long, NASA expects the power margin to shrink to the point where even the final science instrument can no longer be kept alive. The radio signal may persist for a while as engineering communication, but the science mission will have ended. No more field measurements, no more plasma waves, no more direct data from interstellar space. The most remote scientific outpost in human history will go silent. And there is nothing in the current pipeline. No planned mission, no approved program, no spacecraft under construction. That will be able to replace what Voyager 1 gives us, because no replacement is coming anytime soon. The next time humanity sends a probe to interstellar space, if it ever does, it will take another several decades just to reach the heliopause. We will have been blind to interstellar space for an entire generation before we see it again. That is the real loss, not the spacecraft itself. Metal and electronics and decaying plutonium, however miraculous in their assembly. The real loss is the data. The real loss is the irreplaceable, one-of-a-kind, nothing else like it anywhere on Earth stream of measurements from a place humanity spent billions of years looking up at and wondering about. The real loss is the conversation. The longest conversation we have ever had with the cosmos, ending not with a dramatic final transmission, but with a gradual fading, a slow diminishment, a narrowing to silence so quiet that most people won't even notice when it finally stops. And perhaps that is the most unsettling part of all of this. Not that Voyager 1 is dying. Everything dies. Not that its instruments are shutting down one by one. All machines fail. Not even that the golden record will drift through the universe for billions of years without anyone to read it. That is beautiful. And strange, and one of the most haunting facts in all of human history, but it is not the thing that should keep you up at night. What should keep you up at night is the possibility that we, as a civilization, will let this moment pass unexamined. that we will be distracted by the noise of daily life while something genuinely irreplaceable quietly disappears, that the last signal from the most distant human-made object in existence will arrive at a receiver dish in Goldstone or Canberra or Madrid, will be recorded in a database, will be analyzed by a handful of dedicated scientists, and will then be over, and most of the world will never know what happened. Because here's the question nobody is asking. What does it say about us that we built something capable of traveling beyond the solar system and crossing into interstellar space, but we cannot find the resources, the political will, or the cultural urgency to plan what comes next? What does it say about our relationship with the future that the only probe humanity has ever placed in interstellar space is running on its last 2 instruments, and the plan to replace it does not yet exist? Voyager 1 was born from a civilization that looked up and decided to reach. What are we deciding right now? The spacecraft is still out there. Voyager 1 is currently about 25.40 billion kilometers, roughly 16 billion miles, from Earth. It is moving at 38,000 miles per hour, and it will never stop. Its 2 remaining instruments are still measuring the magnetic fields and plasma waves of interstellar space, still sending back data that scientists are still analyzing, still adding to the only direct data set of its kind in the world. The engineers at JPL are still fighting for it every day, planning the Big Bang upgrade, monitoring power levels, calculating risks, making impossible decisions with calm professional precision. They are doing their jobs with an excellence that deserves far more recognition than it receives. But the clock is running. And the question hanging over all of it, the question that should feel like a weight on the chest of every person who hears it, is this. When the last instrument on Voyager 1 finally goes dark, when the last signal fades into the background noise of the universe, when the conversation that began on September 5th, 1977 finally, irrevocably ends, will we have been paying attention? Will we have listened closely enough to what it was trying to tell us? Or will we look up one day and realize, too late, that the most extraordinary thing our species ever sent into the darkness has finally gone quiet, and that we barely noticed it happening? The signal is still there, for now, and if you listen carefully, you can almost hear it.